Yeah. Okay.
I can also join this.
Oh, you can. Link one. Everyone. Mail ID, sir. Is it? Dinesh. DINESH. NATT. Dinesh Tam. Double T.
Thank you.
Sir, good evening, sir. Swaminathan, sir. Dr. Swaminathan, sir. Good evening.
Good evening, sir.
Welcome.
Yeah, good evening, sir. How are you, sir?
Fine, sir. How about you?
Fine.
Thank you. கந்த சஷ்டி கவசம் போட்டுருந்தீங்க உங்க இதுல மொபைல்ல சூப்பரா இருந்தது, நல்லா பாட்டு.
ஓகே.
ரீசெண்டா பழனி போயிட்டு இருந்தேன், பழனி பாதயாத்திரை போயிட்டு இருந்தேன் போன வாரம்.
உத்தரம் போயிட்டு வந்தேளா?
ஆமா, பங்குனி உத்து கரெக்டா சொல்லிட்டீங்க. நல்லா இருந்தது. இட் வாஸ் a very good trip. ஹர்ஷா சார் ஜாயின் பண்ணிருக்காரு, அமெரிக்கால ஜாயின் பண்ணிருக்காரு. பேசினேன்.
இல்ல வந்துட்டாரா அவரு?
உள்ள வந்துட்டாரா? சார்.
He has come to India.
Okay, he has come to India. Okay.
ஒரு
அமெரிக்கால இருக்காரு நினைச்சிட்டேன். இப்ப பேசினேன், உள்ள வந்துறேன் அப்படினாரு. ஸ்கிரீன்ல ஷேர் பண்ணி பாக்குறேன்னா பாத்துங்க.
இல்ல பாக்கலாமா?
நமக்கு ஒரு டபுள் இன்சூரன்ஸ். மாரிமுத்து, ராஜேஷ்
சார் சொல்லுங்க சார்.
செக் பண்ணுங்க. சாரோட இது சாரி ரைட்ஸ் கொடுத்துறீங்களா?
சார் ஸ்டார்டிங்ல கொடுத்துறேன் சார். ஒண்ணும் பிரச்சனை இல்ல.
வருது இல்லையா?
ஓகே சார். ஷேர் சார்.
ஓகே.
சார் யூடியூப்ல லைவ் போட்டுருக்கு சார். அப்படியே லைவ் ஓடுது.
Swaminathan sir, 5:35 will start, sir. 5 minutes, sir. We will wait for the people. People are joining. Right, sir. Right.
Already it is 5:31.
Sir, Professor, good evening, Karapasamy. Sorry, sir, நல்லா இருக்கீங்களா? உங்க வாய்ஸ் வரலையே. I am not hearing your voice, sir.
Sir, now I am audible.
Now you are audible, sir.
Very good, very good. என்னாச்சு எம்எல்ஏ ஆவீங்கன்னு பார்த்தேன்.
ஆமா.
நமக்கு தெரிஞ்ச எம்எல்ஏ ஒருத்தர் இருக்காருன்னு சொல்லிக்கலாம்னு. பரவாயில்ல பரவாயில்ல. இந்த தொகுதி அப்புறம் இந்த எலெக்ஷன் கண்டக்ட் பண்ணலாம்.
ஆமா ஃபுல் இது கான்ஸ்டிடியூன்சி கவர் பண்ணேன், பிரச்சாரம் எல்லாம் ஹெவியா பண்ணேன்.
ஓ வெரி குட் வெரி குட் வெரி குட் வெரி குட்.
ஒன்னும் எந்த இதுவுமே குறை வைக்காம பண்ணேன்.
வெரி குட் சார், வெரி குட் வெரி குட் வெரி குட்.
ஒரு திருப்தி, ஒரு எக்ஸ்பீரியன்ஸ், அவ்வளவுதான்.
இந்த துணிச்சல் யாருக்கும் வராது.
ஆமா சார்.
ஹலோ சார், ஃபர்ஸ்ட் அட்டெம்ப்ட் ஃபெயில். இவருடைய நம்ம ஃபர்ஸ்ட் அட்டெம்ப்ட் லேர்னிங் அப்துல் கலாம் தான். அடுத்து நெக்ஸ்ட் பை சார். குட் ஈவினிங் சார்.
ஹலோ சார்.
ஹலோ சார்.
எங்க சார், எப்ப சார் இந்தியா லேண்ட் ஆனீங்க?
ஒரு வாரம் ஆச்சுப்பா. லாஸ்ட் சண்டே.
தெரியாது சார், சாமிநாதன் சார் சொல்லி அந்த ஹர்ஷா யுஎஸ்ல இருக்கே நினைச்சுக்கிட்டேன் நானு.
இல்ல
யுஎஸ்ல இருந்து பார்ட்டிசிபேட் பண்றான்னு நினைச்சுக்க வேண்டியதான்.
ஆமா, அதான் நினைச்சுக்கிட்டேன் நானு.
குட் ஈவினிங் சார்.
சங்கரன் சார். குட் ஈவினிங் சார். சங்கரன் சார்.
செல்வராஜ்.
குட் ஈவினிங். குட் ஈவினிங் டு ஆல். குட் ஈவினிங்.
குட் ஈவினிங் ஆல். குட் ஈவினிங் ஆல். குட் ஈவினிங் சார். சொல்லுங்க கருசாமி சார், சொல்லுங்க.
இந்த நெய்வேலி ப்ரோக்ராம் அட்டெண்ட் பண்ணிட்டு இருந்தேன்.
சரி, ஓகே.
என்ன ஒரு இண்டஸ்ட்ரி இதுல டே டைம்ல நடத்துறாங்க, ஒரு 20 பேர் கூட இல்ல.
எல்லா இடத்துலயும் அப்படிதான் இருக்குது. நம்ம எந்த அளவுக்கு இது பண்றோமோ அந்த அளவுக்கு தான் பீப்புள் வராங்க.
இண்டஸ்ட்ரி ஒர்க்கிங் டைம்ல 4 o'clock நடத்துறாங்க, ஒரு கொஞ்சம் பேராவது அட்டெண்ட் பண்ணிருக்கலாம்ல.
ஆமா, பண்ணணும்.
இப்ப நான் இது இடையிலயும் ஒரு 6 மணிக்கு நான் இது சென்னை மீட்டிங் போயிருவேன்.
ஓ சரி.
அதுவும் 6 மணிக்கு. அது
ஓகே ஓகே.
6:30க்கு மதுரை மீட்டிங் வரிசையா.
6 மணிக்கு முடிச்சிரும், கவலைப்படாதீங்க.
நல்லா அவர் பேசினாரு சார். இந்த இதுல நெய்வேலி இதுல சிரவன் ஒருத்தர் பேசினாரு. அவர் வந்து இது இந்த கங்கா ப்ராஜெக்ட் எல்லாம் கவர்மெண்ட் இது ஆளுகளுக்கு எல்லாம் டீட்டெயிலா அந்த ரிவர் கிளீனிங் எல்லாம் பத்தி எக்ஸ்பிளைன் பண்ணாரு. என்னென்ன இதெல்லாம் இருக்குது, இப்ப என்ன இம்ப்ரூவ் பண்ணிருக்கிறோம்.
கருப்புசாமி, டாக்டர் சுந்தரமூர்த்தி ஒருத்தர் இருந்தாரு, அவர் பையன் தான் அங்க ப்ராஜெக்ட் மேனேஜரா இருக்கான் கங்கா கிளீன்சிங் ப்ராஜெக்ட்ல, டெக்னிக்கல் சைடு, வாட்டர் சைடுல.
நம்ம சுந்தரமூர்த்தி
வந்து பேசியிருக்காரு நம்ம இதுல இன்ஸ்டிடியூட்ல. உங்களுக்கு தெரியுமா தெரியலாம் தெரியாது. அவர் பையன் டாக்டர் சக்தீஸ்வரன் இஸ் a ப்ராஜெக்ட் டைரக்டர் தேர்.
இப்போ சிரவன் ஒருத்தர் பேசினாரு. எப்படி சார் இருக்கு உங்க ப்ரோக்ராம் எல்லாம் முடிச்சிட்டு நல்லபடியா வந்துட்டீங்க எல்லாரும்? யுஎஸ் முடிச்சிட்டு
ஸ்டார்ட் பண்ணலாமா சார்?
சார் ஸ்டார்ட் பண்ணலாமா சார்? செல்வராஜ் சார். செல்வராஜ்.
செல்வராஜ் மியூட்ல இருக்கீங்க. நீங்க மியூட்ல இருக்கீங்க. நீங்க பேசுறது எதுவும் காதுல விழல.
செல்வராஜ்.
செல்வராஜ்
மைக் அன்மியூட் பண்ணிட்டு பேசுங்க. ஸ்டார்ட் பண்ணலாம்.
Sorry, I did not mute it. Actually, unmute it. Sorry, very sorry. Happy good evening to everyone. Today we have an interesting. We are celebrating World Water Day as per the direction of our IEI headquarters in the theme groundwater making the invisible visible, and it is going to be delivered by eminent personality, our very well-wisher and our very good friend of IEI TLC, our friend at NIT, Dr. G Swaminathan, Professor HAG, and head of Department of Civil Engineering, NIT Trichapalli. First of all, we thank you, sir, for accepting an invitation to be the chief guest of today and to deliver the talk about the theme. We are very much happy to receive you, sir, in our platform.
Thank you. Thank you, sir.
And I welcome our past chairman Harsha sir, Sankaran sir, Karpusami, Dr. Karpusami sir, other Madhavan sir, other our committee members, citers, other committee members and other invitees for today's celebrating for World Water Day. This is the 119th program in online virtual platform. Previously, we were doing the past 3 decades IEI TLCs, propagating and disseminating the emerging technologies in all the 15 disciplines to all our members of the society regularly for the past 3 decades. And before the pandemic, it was in physical mode. We conducted the program at our APJ Abdul Kalam Hall, situated in BHL campus. Now we are switched out after the pandemic, April 2020, we switched out to this virtual mode. This is our 119th program. So we are a role model for all the professional bodies to conduct technical programs regularly. So with this note, I call upon Engineer Sankaran sir, our past chairman, past executive director of BHL Trichy, BHL Vizag, to preside over and welcome the gathering, sir. Over to Dr. Engineer Sankaran sir. Sankaran sir?
Yeah.
Yes, sir. Please, sir.
Thank you, Saluraj.
Yes, sir.
Good evening to one and all who are participating in today's program. At the outset, I would like to welcome the chief guest for today's program, Dr. G Swaminathan, Professor and HOD of Civil Engineering Department at NIT Trichy. Dr. Swaminathan is very much associated with the IEI TLC for very many years, and he is well known to all the members as well as office bearers. So he is a person who is very much familiar and doesn't require any introduction. And at the same time, I would like to thank Dr. Swaminathan for having accepted to deliver today's theme lecture on the occasion of the World Water Day. It gives me a great pleasure to preside over this function today as the present chairman of IEI TLC could not join in time because of his preoccupation with his official duties. I welcome the past office bearers, present office bearers of IEI TLC, and all the members and invitees for this today's online lecture program, and who have taken interest to join this program amidst their busy schedule this evening. So IEI TLC is conducting this World Water Day program for very many years, and as usual, like any other special programs, this year also IEI TLC is conducting the World Water Day program, and the theme for today's program is groundwater, making the invisible visible. So the groundwater is nowadays becoming a scarce commodity, and water being the much essential thing for a human being to live in this earth, whatever action we take to preserve water, it is welcome for the humanity to survive, because the basic survival itself has become a question mark in the absence of water. And whatever water is available, other than consuming the water, everyone should take action to conserve and preserve the water also, so that we will leave something for the next generation to carry forward. And all the other than human beings, all the lives to be present on this earth. So with this introduction, I would now request Dr. G Swaminathan to take over the session and then deliver his World Water Day theme address. Thank you, one and all.
Thank you, Engineer Sankaran sir, for a nice warm introduction, as well as telling about the importance of our groundwater. Thank you, sir. Thank you for sparing your time, being with us, for welcoming the gathering also. Thank you, sir.
Welcome.
Yes. Now, before, for the interest of the participants, just I'll read out the World Water theme, which is given by our Aksha sir from the NET, from the World Water. I just read out the World Water theme. That is World Water Day on 22nd March every year. Is about focusing attention on the importance of water. This year's theme is groundwater draws attention to the hidden water resource that has always been critically important but not fully recognized in sustainable development policy making. Under the title Groundwater, Making the Invisible Visible, this year's campaign will explain groundwater's vital role in water and sanitation systems, agriculture, industry, ecosystems, and climate change adaptation. The overreaching message of the campaign is that exploring, protecting, and sustainability using groundwater will be central to surviving and adapting to climate change and meeting the needs of a growing population. Groundwater is invisible, but its impact is visible everywhere, out of sight, under our feet. Groundwater is a hidden treasure that enriches our lives. Almost all of the liquid freshwater in the groundwater is groundwater. World is groundwater. As climate change gets worse, groundwater will become more and more critical. We need to work together to sustainably manage this precious resource. Groundwater may be out of sight, but it must not be out of mind. Oh, this is the theme of the World Water Day. This is being given by our Harsha sir from the net he has downloaded and gave us. Thank you, sir. Thank you, Dr. Harsha sir. And now moving on to the next agenda, I call upon Dr. Titus, our committee member, to introduce our Dr. G Swaminathan sir to the participants. Over to Dr. Titus. Dr. Titus? Titus sir? Are you there? Titus? Is
Sir,
there yes, sir. Please introduce the GSR, Dr. G Swaminathan sir, Professor, HSG and Head of Department of Civil Engineering to our participants, sir. Please. Sir.
Okay, sir. Thank you, sir. Thank you for the opportunity given. Very good evening to one and all gathered here. I am very happy to introduce today's chief guest of this forum, Dr. G Swaminathan sir, who is the head of the department in Civil Engineering Department in National Institute of Technology, Tiruchirappalli. So on behalf of Trichy IEI local center, I warmly welcome our today's chief guest. So I am happy to introduce the chief guest of this forum, Dr. G Swaminathan sir. He started his engineering as a teacher from 1988. His area of specialization in environmental engineering, PhD from IIT Madras and ME from Anna University and BE from Anna University. Currently, he is working in environmental engineering, water supply distribution network, and co-processing and energy storage. Sir was expertise and he has a very good experience in various levels and various authorities. From 1997 to 1998, he started his career as an engineer and then he has become a professor. And he's also acted as a nodal officer in TechUp, and he has also acted as a dean and administration in NIT Trichy, and he is also a coordinator for administration in NIT, and he is head of the Department of Energy and Environment at NIT. He has also acted as a registrar in charge administration in NIT Tiruchirappalli during the year 2012 to 2015, and he is also an advisor for 2014 to 17 in TechUp in NIT Trichy, and also a coordinator for administration legal cell at NIT Trichy during the year 2015 to 2018. And then from 2017 to 2015 to 2017, he has acted as a Dean Administration Planning and Development at NIT Trichy. And also presently from 2019, Sir is working as a head of the department in the Department of Civil Engineering in National Institute of Technology, Tiruchirappalli. Sir has completed his BE degree in 1984 and he has completed his PG course in 1987 and completed his PhD research from NIT, from IIT Madras during the year 2000. And also Mr. Professor G Swaminathan sir has received many honors and awards. During 2016, he has received Rekha Nandi and Lopesh Nandi prizes. 2018, he has got the certificate of appreciation from NIT Tiruchirappalli, and 2019 he got the best engineering award from the Institution of Engineering Tiruchirappalli. And sir has guided many PhD scholars from the year 2007. He has produced many PhD scholars from his expertise. And sir has also done received many research projects in various disciplines from in environmental science and engineering. And Dr. G Swaminathan sir has published many publications in the reputed journals. More than 53 papers were published in the reputed journals. And also he has acted as a co-author for more than 76 papers for this publication. So with this introduction, I would like to welcome our today's chief guest, Dr. G Swaminathan sir, to present the lecturer on theme groundwater, making the invisible visible. Once again, I welcome you, sir, and I welcome you all the participants, and thanks for the opportunity given for me to welcome the today's chief guest. Thank you, sir. Thank you.
Thank you, Dr. Titus. Thank you for a nice introduction of our today's chief guest, Dr. G Swaminathan. Now the session is open to, we are looking forward to hear from Dr. G Swaminathan, our best engineer of IEI TLC and a best friend of us, and also is a bridge between BHL and NIT, as well as IEI TLC and NIT. He is long associated with us. Thank you, sir, for all your association over the years. Now looking forward to hear, sir. Thank you, sir. Please over to you, sir.
Thank you. One minute, I will share the files.
Please, sir.
Is the screen visible to you, sir? All of you are able to see.
No, sir. No, we are able to see, sir. Only your file is seen, sir. World Water Day file is seen, that icon, but we are like to see the PowerPoint, sir.
Yeah.
Yeah. Still, it is not the screen. Only the files, file is seen.
Hello.
10 files, the file தான் தெரியுது. The folder தான் தெரியுது. Folderல inside உள்ள file தெரியுது.
வரலையா?
வரல. வெளியே போயிட்டு வரதா வாங்க, ஒண்ணும் பிரச்சனை இல்லை. If you can go out and come. வந்துருச்சு சார். இப்போ வந்துருச்சு சார். Thank you, sir. Now it has come.
Good evening to all. It's a wonderful opportunity given to me for sharing some of my ideas in the area of water. The World Water Day 2022. It coincides with the Tuesday, because every Tuesday you can count on a lecture from IEI. It so happened that we are very fortunate that we are observing the World Water Day on exactly the Tuesday. It happened to be a day, and that's a day go without a lecture from IEI. I'm very fortunate that I've been associated with IEI for a long time. Even after defending my PhD thesis, my first lecture outside the institute was an institution of India. My friend Harsha also may be remembering that was a wonderful nostalgic memories have been recalled by this. Very good. is my lecture. I just planned it because the water is a subject which flow, but when it is being taught, it is very dry actually. So then and there I have added some spice about water quality, and I also combined my experience in this front. Kindly bear with me. At any point of time, you can stop me rather. And whenever we go on a double carriage road of BHL, one slide used to be very, very impressive and interesting, which says that water is elixir of life and don't waste it. Then I was just wondering what could be that. Elixir of life, what is the basic meaning of it? When I refer to it, we find that a substance held capable of changing base metal into gold. So whether water will change into gold, and a substance held capable of prolonging life indefinitely, cure and medical concoction, a sweetened liquid usually containing alcohol that is used in medication, either for its medicinal ingredients or as a flavoring, because all of us know that water is colorless, tasteless, and odorless. But when you add a sweetened liquid, how a water can be elixir of life actually. But that's the real sense. Elixir of life, also known as, it is the one which creates what is called immortality. And this is a potion. Potion is a French word. Supposedly grant the drinker eternal life or eternal youth. So these are all the meaning for elixir. So water, of course, without water, how come we can survive? The amount of water what is available in the planet, when the planet has come into existence, it never changes. Over a period of time, what happened? The quality of water is getting deteriorated. And we land in a place where you have to select a particular day and observe it. But I cannot say that it is we celebrate a water day. How can you celebrate a water day? Or something is going to be a scarce item over a period of time. And it is that awareness what is being created to make ourselves a retrospect and find out what is available in the. So we have collected some data, and that is that we are going to present it, and how, and my own experience are shared here. So historical background in the United Nations General Assembly, as Selvaraj was mentioning, they have adopted in 22nd December 1992 that March every year been declared as a World Water Day. What is the objective of the World Water Day? And of course, we have included celebrate, but to observe the raising awareness of 2.2 billion people living without access for safe water. Because if you remember that one day, some 2 years back or 3 years back, when in Johannesburg, they declared that from that day onwards, it is going to be a no water day for the whole of the country together. A country going without a drop of water. What is that? So how we manage the resources and what is our, because the anthropological way how a man has created the water crisis. So to encourage the member states to take action and to take a global water crisis and achieving something, water and sanitation for all by 2030. We have been advocating it for a long time, that the whole India, we are slowly achieving the goal actually. So we had what is called the water and sanitation decade actually by 1980 to 90. And slowly that we have to, the planet what we have inherited from our years, that is the young blood of tomorrow, we have to hand over the planet. So also the important liquid water. But the here theme is making the invisible visible rather. So that we will add to that. Groundwater has been a major source of water for sustaining human life actually. So people, when you look at a civilization, wherever there are rivers, we have got a civilization. Either it's an Indo-Gangetic plain or a Mayo civilization or the Euphrates and Tigris, that Mesopotamian civilization. All these things had origin only by the riverside because river was supporting the lifeline. That water was infiltrating into it. Slowly, man started tapping it, and when he invented a wheel, his job of bringing a water from a down below the ground level to that level. So only the invention has made the job easier. So the groundwater has become a very important resource. But now what is the state? It has been increasingly polluted due to industrial, domestic agriculture and environmental activity. Because the environment, everybody is responsible for the upkeep of environment. Everybody is associated with the environmental damage one way or other. So that is the status today. So groundwater resources or reserves are diminishing due to over exploitation. So that man is a greedy animal. In other regions, groundwater are underdeveloped actually. So water is available. What was the water availability in the planet is depleting over a period of day actually. Even today we have a statistics. What is the freshwater availability in the planet? Depletion of groundwater, a precious resource for agriculture, ecosystem services and domestic supply, has the potential to cause a significant interruption of societal and ecological functions. So this is one which we are concerned about it. So what is our job is to manage, use and protect the groundwater resources in a sustainable way rather. So fact about the groundwater is the world's most extracted raw material with withdrawal rate currently in the estimated range of 982 kilometer cube per year. So about 70% of the groundwater withdrawn worldwide is used for agriculture. Major uses is the agriculture. And groundwater provides almost half of all drinking water worldwide. We take it because it is taken from a source. I never disputed, but I never agreed to it also. Globally, about 38% of irrigated lands are equipped for irrigation with the groundwater. The total volume of groundwater in upper 2 kilometers of Earth continent crust, not inclusive of high latitude North America, is approximately, which is 1.1 million kilometer cube to 5 million kilometer cube, less than 50 years actually. Volume of modern groundwater is equivalent to a body of water with about a 3 meter spread over the continent. So these are some data which we make us what is called the fact rather. Formation of, because the main source of water is only the precipitation or the rainwater, because that infiltrates into the ground. If the hydrological cycle is not there, long back we would have started drinking our own sewage rather. But because of the hydrological cycle, water evaporates and then it goes out and then it rains out. But we are not mastered completely what is the technology of rain. Had we done that, our world would have taken a different shape or so. But some nature is helping us. Somewhere it rains and once in 4 years you used to have what is called a flood and what is called as a drought. But now what happened? The season has shifted because of the man-made activity. Surface water has become trapped in the pore space of the sediment during the deposition in lake because the surface water infiltrates into the ground. The part of the rainwater also infiltrates and it saturates the ground. A part water it flows over and we call it as a runoff in civil engineering terminology. Some part of the water which infiltrates into the ground and it make a travel vertically till it reaches what is called the impermeable stratum. This impermeable stratum may be a clay which has got the porosity to a lower order because it is being defined as the permeability constants of the particular soil. So the soil mass has got porosity. Through the pores, water enter into it, and that has caused what is called the groundwater. Major source of groundwater is only that. And of course, water degassed from cooling magma, because when the volcanic eruption, when cooling occurs, something happens, and the metamorphic reaction that break down hydroxide of the minerals. So something happen in the ground actually. Metamorphism is a change because we have got what we call the volcanic rock, igneous rock, the sedimentary rock, and the metamorphic rock. The limestone, when it metamorphoses, it becomes what is called the marble rock. Same way, carbon, when it undergo a change, it becomes a graphite, a one-dimensional conductor, and then it becomes a insulator when it becomes a diamond. All these things, it is called the metamorphic reaction because of the pressure inside and altering of the structure of the compound. But diamond is also a carbon, charcoal is also a carbon, coal is also carbon. All happen because of what is called the metamorphic reaction. The large portion of world freshwater resides underground, stored within cracks and pores in the rock, which constitute 14.2% of the Earth freshwater. If you look at it, the planet is surrounded by water, but what is the water? Freshwater availability is dwindling down. What was 3% a long back now become a 0.68%. So this is the fact about water. Groundwater supplies half of all drinking water in the world. Many of the cities, they are using the groundwater. For example, if you look at town of Pondicherry, the whole town is fed only by groundwater.
ஏன்னா நாள் தள்ளி போகுதுங்க, அதனாலதான்.
World aggregated groundwater abstraction is 1,000 kilometers cube per year per year. Like so, this much of water is being abstracted from the planet. The groundwater is very important natural source and a significant role in the economy, because we will see it later on. And irrigation happened to be the main source. More than 70% of the total water withdrawn, both surface and groundwater. Groundwater is estimated to be approximately 43% of the total irrigation water use. Groundwater is because I just wanted to tell you that what is the main, that is the source of water, which is naturally available water, which is very pure. The answer is very, very scarce item. Something is available in the, because we used to say that rainwater is the more pure form of water. But it go with a rider because water is a universal solvent. Whatever comes on its way, it dissolves. That is the quality of water. But that is the quality which is detrimental to the water getting impure, because it dissolves everything. Because except for few organic substances, it dissolves it. But the groundwater, because it flow into the ground, because interstices of the particle, it acts like a filter, and then it filter out what is called the suspended impurities. But there is something called the theory of filtration, guided by what is called sedimentation and absorption, nuclear metabolism, electrolytic action, and mechanical straining. So these are what is called the major principle of filtration. So water, when it passes through these media, it gets filtered out. Not only the suspended impurities are removed, also the dissolved impurities are removed. So the ground is acting like that. But when it goes below, some mineral deposits are there. When it flows over, being a universal solvent, it dissolves that, and water get the deterioration of the quality get from. So these are some of the things which we have to think of, because some part of it we are getting a good water, somewhere we don't get the saline water is very saline. Additionally, it's a natural source which can be found close to the most important news about it, right balance between withdrawing and aquifer level to avoid over exploitation, to avoid pollution of these crucial resources. So before 17th century, many natural philosophers accepted a Greek theory. They say that how that the seawater is getting purified. But later on, they proved that it is only the groundwater, which is the surface water, which is infiltrating, because this is the revival of writings of Paragamigara and Muhammad Karaji in 10th century. Because nowadays we are talking about it, the water divining itself is very difficult with all the gadgets. We are trying to find out where the water is. But somehow the people were able to do it with natural agency, which I will not go into it because it's for a time constraint rather. The hydrological cycle, as I was telling you, the main source happened to be the precipitation or the rain, which infiltrate, and then part of it becomes a surface water and part infiltrate into the ground, and it becomes a part of the groundwater, right? So where that occurrence of groundwater, the receptacles of water is the rock actually. All rock contain opening through which water will flow, especially near the surface of the earth. In some cases, the rate of flow is almost immeasurable because these openings are so minute and disconnected. I tell you that sometime back when we go for what is called water harvesting rather. So BHL also done it, and they abandoned the quarry is being used the storing of the rainwater. But slowly these water infiltrate, and the beneficiary happened to be NIT Tiruchirappalli. On the eastern side of our Opal hostel, we got a very good well. The yield of the well is very, very good actually. In fact, there was a query whether the Kaveri water is supplied, because people think that we get a water from Kaveri. Originally, we are part of BHL and Tiruchi. BHL, the major consumer, and we are part of, we received from water from Bangalore. And our people were contesting whether the people on the teaching side is being given a Kaveri water and the non-teaching being given the groundwater. So how to convince them? At that time only we started the environmental engineering laboratory. We tested the water. The Kaveri water was found to be relatively, I don't say impure, relatively less pure than the groundwater. So how the water goes and water finds, because three things in common: the power flow from higher potential to lower potential, water flow from higher plane to a lower level, and wherever there is a path of least resistance, it takes a force. When the force in the water, how it happened? Because something is below the ground, and it so happened that water flows through the this thing. That's why it is the size, shape, and arrangement of openings are highly variable. Technically, the openings are called voids, pores, and interstices. Molecular attraction in water and rock. So that I was telling you, the purification of water is by what is called the theory of filtration. One is addition. If an intermolecular force exists between unlike molecule, then it is called adhesion. If it between the like molecule, it is called a cohesion. So the rock will try to adhere the water. And then, of course, the water has got what is called surface tension and capillarity, which we are very familiar with that. And permeability of rock, that is the one, because what the rock in general we are talking, but it holds good for sand or soil also. And then a coefficient of permeability, because the coefficient of permeability has been dictated by what is called a Darcy law. Darcy law says that the flow, because they put a Q, but it is actually V. V is the velocity. Velocity is a function of the hydraulic gradient given by dx by dl and is equal to some K. K is what is called the constant of proportionality, which is called the hydraulic conductivity, the hydraulic gradient, which drives the water to flow. This is the theory which is applied for open well hydraulics, confined aquifer, unconfined aquifer, but this is the basic law. When the K value is very, very low, in the order of 10 power of minus 9 centimeter per second, we call that the finely grained soil, which will not allow the permeation of the water through the pores. The pores are closed almost. That we call it as what is called the impermeable layer. This impermeable layer could be a clay, but later on what happened? The clay also undergone what is called the ion exchange. The property of the clay changes. How to conserve it, because the theory is no more valid. Those days you used to have a septic tank, and when you identify a well, people used to say that there should be a horizontal separation of 20 meters and a vertical separation of 5 meters. This theory and all gone nowadays, because there is a reactive component of the soil. The soil also changes its course over a period of time, because there is something called the chemistry of it. Water also flow, and the water quality also deteriorates. That is a chemistry there. The soil also has got some minerals. The minerals also get exchanged when water flows through that. The exchange of the mineral, and many theories are there, which has resulted in change in the property of the soil, because what is called the a non-expansive clay become expansive clay because of the water and the soil interaction. So we limit ourselves that the quality of both the things are inherently affected rather. So this is a figure which shows what is called the confined and the unconfined aquifer. This, what is that? The second layer of it, what is called the confined aquifer. So it is under pressure. When we went for an open cut mine of a Neyveli, we have got what is called the artesian aquifer. The water was gushing at a high pressure because there is an overburden pressure, and the water transmits the pressure by what is called the law of nature rather. So confined or artesian groundwater is separated from atmospheric pressure. The water is available at a very high pressure rather. So we classify the wells also as what is called the deep well or a shallow well. A deep well is the one which receives its water from more than one aquifer. If it taps the water from the topmost aquifer, we call it as a shallow well. So unconfined aquifer is the confined aquifer, the water will be under high pressure rather. Then we talk of what is called a spring groundwater. If it oozes into the ground by means of a fissure in the rock, when it comes to the surface, we call it as a spring. Okay. So this is a small diagram which I took it from internet. So water is oozing from somewhere else. There is a crack in the rock, and then it comes out. But nature, we cannot understand the nature. Sometime back, some 5 years or 6 years back, I had been to a place called Badrinath. Badrinath is around 8,000 feet above 8,000 to 10,000 feet above mean sea level, very chilly area, where there is a place where river Alaknanda, one of the tributary of Ganges, originate. When you stand in the river, within no minute of time, you will feel the numbness, because it is a ice water melt that comes in the river. But when you go to the Badrinath, there is something called a hot water spring. There we have got that height in the Himalaya. Because there are mythological stories, but understanding the nature becomes very difficult rather. When there is a ice melt in a 5 meter to 10 meter level, and the horizontal separation, there is a place called Saptakunda, very outside the holy temple of Badrinath, where hot water springs are available. That's a very wonderful experience rather. So artificial recharge, because the groundwater is depleting, what we should do? Because the Pondicherry, there is a place called, don't remember the place, because there is a groundwater reservoir, because Pondicherry, as you know, that the whole city of Pondicherry is below the mean sea level rather. At one point of time, because the sea is traversing inward. Everywhere, wherever you go, very near to the shore, we will get only a saline water. But from the place that's called Mutrayabalayam, that's called Mutrabalayam now, there you have got a wonderful yield of groundwater. But groundwater authority says that we are over exploiting. This is a story of 25 years back. At one point of time, when the saline water hit up there, what will happen? The water, the reversal of the flow, because Mutrabalayam is at a higher elevation, because water, they store it in a reservoir, and then by gravity, it comes and fill in the forward tank in the city of Pondicherry. But the groundwater authority says that you have to protect this groundwater rather. At one point of time, when the aquifer is polluted, there is no, the change becomes irreversible. So artificial recharge, how to do it? You have to drill it and then go for pumping water again into the ground itself. So all these methods have been adopted rather. So what is the artificial recharge is practiced? Conserve and dispose of runoff and flood water. Of course, many times we are talking about there is a flash flood, water go into the sea. So supplement the quality of quantity of groundwater available, reduce or eliminate decline in the water level of groundwater reservoir. But that is a major thing which will cause the intrusion of saline. Reduce or balance salt water intrusion. That we have to wake up and then we have to go, we have to take action because it is only a question of head. If freshwater head is above the salt water level, water flows because there's something like a membrane, is a transmission of water through the membrane. If the salt water level rises up other than the fresh water, what will happen? The salt water, the reversal of the flow starts and resulting in the damage of the aquifer. So store water to reduce the cost of pumping and piping. Because these are some of the things which is possible and we are to do it. And store water in off season for use during the growing season. Because what is that we learn as a science, it is being practiced in other countries, but we learn it as a science, we get a degree, but we don't practice it. Conserve energy in geothermal application. Remove suspended solid by filtration through the ground. Of course, we in NIT, we are getting water only from a groundwater source. It is called an infiltration gallery. Infiltration gallery is relatively, I don't say that it's superior source, it is relatively a superior source than other source of water for a simple reason. Water infiltrates and flow into the open jointed porous pipe and get collected. To increase the yield of the infiltration gallery, what we should have done is we should have gone for a check dam and allow the water to infiltrate more into it. These are some of the measures which we can take it up so that the groundwater level can be increased. But if you look into that, there is a river Kaveri. In the other side, we have got a river Kolirun or Kolidam. But when you go down, actually, in the groundwater, you can see that there is a flow of water from Kaveri to Srirangam. But nowadays, what happened? We've gone for construction activity has prevented the natural flow, right? Because in Trichy, that area, we don't have what is called a multi-story apartment. We have gone for it. And the soil in that area happened to be loose. Then we have to go for a pile foundation. The pile foundation offers resistance for the natural flow of water. Most of the flash flood occur because that we are meddling with the water resources or the course of the water. That is the reason, right? Okay. The groundwater status in India, India is the most water challenged countries in the world, from its deepest aquifer to the largest river. The groundwater levels are falling as Indian farmers, city residents, and industries drain wells and aquifer. What water is available is severely polluted. So 50% the demand will, the scarcity increases, and we foresee that there is going to be a demand in 2030. But we just will bypass it and we'll go to the another presentation which I made it. Water, Elixir of Life, we have discussed it. So this is because when you look at the freshwater ecosystem, ocean 97.41%, only 2.59% of freshwater is available, right? The freshwater availability is dwindling. This slide was made 20 years back. But now what happened? This has become 0.68%, but the other way, the same thing exists rather. Right. If you compare the total water availability in the planet as 100-liter can, and the freshwater availability is only a 3-liter can, and what is readily available is only a teaspoon of water, what is available in the planet. So this is the measure of this. This is the groundwater. But water is a universal solvent. People say that water is colorless, waterless, and tasteless generally. But for scientific reason, even our water, because being a universal solvent, water contains color, but of course it doesn't have a water. But somebody calls us water as a taste. Somebody in very much attached to Kaveri, they will say that Kaveri water is that wonderful water. But what is that we are drinking is a different story. Same way with the Sirvani water, right? So water, natural water, surface lake, groundwater, well, spring, infiltration gallery, other alternative source, we have added ocean, because nowadays people are extracting water only from ocean, and we have gone for what is called the RO technology. I will come to it later on. Okay. Water resources, artificial resources of fresh water can include treated water, reclaimed water, and desalinated water. Because some of the countries which are without water resources, they are managing. But we have got a water resources. Our water resources management is not to that extent. So water quality criteria, it depends upon based on its use, because I am going to touch in a few minutes. Water quality criteria for potable water need not be the same for water used for agriculture purpose, because no farmer go to a laboratory and demand that whether this water is suitable for agriculture purpose or not, because the question arises whether the leaf is important for a plant or a root. That's $1 million question, rather. Right. Quality for industrial need may be stringent than potable water, because water quality, we say that depends upon potable water, industrial need, agriculture need, and construction activity. We classify the potable water into physical, chemical, and bacteriological. Physical impurities include color of water, conductivity of water, and turbidity of water. We have got a standard, but doesn't mean that. But being a water, being a universal solvent, everything gets dissolved in water. Everything getting dissolved in water, and each parameter are discrete by itself. For example, if you got a chloride in water, you got a sulfate in water, and somebody does a test, whether the test is correct or not, we are not in a position, because for that I have written a small program also. I'll show you. So water quality characteristics depends upon the color, turbidity, electrical conductivity, temperature, water, and taste for potable water. Suppose I give a sample of water and say that whether the water is a scale forming water or a corrosive water, these some parameters are interdependent, but most of the parameters are discrete. And for example, if fluoride is available in water, we cannot make it that sulfate will be available, because that is different. Because water being a universal solvent, it dissolves everything, comes on its way. So I will not go into this. So these are the solvents which are getting dissolved in water. For example, sodium chloride, potassium chloride, calcium chloride, and the only exception is the organic substances. Something is sparingly soluble in water.
Sir, excuse me, Swaminathan, sorry to disturb you. The second PowerPoint, is it you are pushing it or only you are talking, sir? Second set, you told some PowerPoint, but only that water Elixir of Life .ppc only is fine.
It is not being visible now.
Not visible, sir. That's what. You are going on talking. You told the second set of PowerPoint. We are not able to see any PowerPoint. That's what.
Sorry.
No problem.
Now is it visible, sir?
Yeah, it's coming. It has come, sir. Now only it has come, sir. You can show from the beginning, sir. Beginning.
The water being a universal solvent, almost every inorganic impurity is getting dissolved in this. Whether it is only exception is some organic substances. But when you look at it, even I can afford to have a cyanide in water to an extent of 0.01 milligram per liter. But compounds like a phenolic compound, which are very carcinogenic, we limited to 0.001 milligram per, very stringent than the finite level. So these are chemical characteristics. And of course, we have got solid, because I said that the impurities in water are discrete and they are not dependent. Most important is what is called the pH of water, because we know that the pH of neutral water is 7. Water being a very good insulator, because the ions available is only to the order of 10 power of -7 per liter, right? It is derived from the word potence, actually. That is why you call the pH, actually. pH of neutral water is 7. But when you want to test the water for corrosivity or the scale formation, we go by what is called the Langlier index, which says that the saturation pH we calculate depending upon the temperature of water and the solids level, calcium content, alkalinity in water. If the pH, the Langlier index is positive, we say that it is a scale forming, because I see it from the industrial perspective, because when water is being used as a coolant water, we require these characteristics. So these are some of the functions of that. Bacteriological analysis, we will skip this. So these are some of the quality criteria for water. And mostly as a civil engineer, we require a water for concrete purpose. Generally, this is the extract from IS 456-2000, which says that potable water is generally considered satisfactory for mixing concrete. When you compromise the quality of water in a concrete, the concrete, because it is a chemical reaction, because it is a formation of tricalcium silicate and dicalcium silicate, which add strength to it. But when this water contains something more of sulfate, it reacts with the alumina and form what is called a sulfo-aluminate, resulting in deterioration of the quality of water in the concrete. So people ask whether this water can be used for a curing purpose. Curing is the one, because the 28 days is the one progressively concrete gains a strength actually. So this is the criteria which is given by a course indirectly to measure what is called the acidity and alkalinity of water. So this is the one which is given for measuring of alkalinity is thought because of presence of hydroxyl ion, carbonate and bicarbonate. It operates between a pH of 4.5 to 8.3 rather. So this is the water that is required for the
syllabus Okay, so what is the set standard going to be then, Professor Kumar? Let's talk about the syllabus itself. How is it going to work for students of different streams?
You see, there are going to be 27 domain subjects in which the CUET will be conducted. You may be a science student, you may like to take admission in BA in psychology.
Yes, not noted it. Anyhow. Okay. The chloride content in water, if you look at it, it has been limited to 500 milligrams per liter for reinforced concrete. This is the change because this is the one which promotes a corrosion.
Also know that as part of the national education policy, we are encouraging in all the universities to help the students study across the disciplines. So the multidisciplinary education is another.
One Mr. Narayanasamy is taking class with his microphone on. Can anybody ask him to put it off?
Or whether they have some other background, they should be able to choose the program of their choice, provided the university announces these choices on their.
Some interference is there.
Teams will now have to do that under the system.
That is what I am saying. If the admitting, for example, in JNU, we admit engineering students to join in MA economics. So such possibilities exist in many universities, and the other universities are also introducing this multidisciplinary education.
Small request for the participant, they can mute your mic system because it is interfering with my lecture. Please.
Yeah, one Mr. Narayanasamy is taking class, I believe, with his mic on.
Our students nowadays we are going for an online system. The major drawback with the online system with the students is that they keep their computer on, whether they are listening to it or not. We are not in a position because the reaction we are not getting it. Okay, but we are used to it. We have been doing it for more than 2 years now. Now we are shifted to the offline classes also. The lovely thing is the class, when you go over and see the reaction of the receiver, that makes the lecturer very comfortable. Okay, fine. We'll go into it. No, because this is something called the irrigation water. Water uptake by the plant is only by osmotic process. Water uptake, the pure water is transferred and by the principle of the transpiration and evaporation, evapotranspiration, the plant, because of the leaf system, is able to store the water. So more of the chemical, which which we are using it never penetrate into the plant system. The plant takes only pure water, and the other chemical more and excess, it remain in the soil solution, and later on it impedes the growth of the plant soil. The part used consumptively, part is used by soil for evapotranspiration. Water retained in the soil is known as a soil solution. Plant takes pure water. This is the theory behind it. So that is why if the quality of water depends upon the soil and the tolerance level of the plant rather. So this is the maximum permissible concentration of trace element in irrigation water. The most important part of it is the sodium absorption ratio and the percentage soluble sodium, which is given by the formula. The maximum permissible value of percentage soluble sodium in irrigation water is limited to 60. It is the cation. What is that? A major cation which is constituting azotic, sodium, potassium, magnesium, and calcium. So this is sodium interference in the plant growth rather. But nobody, I don't know whether anybody test the water and say that we can test whether the water is suitable for irrigation purpose or not. A day will come, everybody will come to the laboratory and then test the water, whether the plant can survive in this water. Because the water quality, that also matters for that. Same as well for irrigation water also. Now the sustainability of video is available. We are able to see a video.
No.
Not able to see.
When we had been to, because we are saying that the sustainability of the water, we go to Singapore, everywhere it is written that wherever you take a water, it is 100% safe and pure. I'm also dreaming of it, how when our country will advocate such a statement, wherever you drink water in India, it is 100% safe. That is, we should work for it, because Singapore, they are purchasing water from Malaysia and slowly they are bringing down the level, and they have gone for what is called the water audit. They're able to sustain their water requirements by collecting the water, because the road has been laid for proper camber, and the width of the drain was such a large, not even a single drop of water. Every water they make use of, that water has been treated, and 2% of the wastewater is mixed with the drinking water, and that being supplied as what is called a new water. So water resources are managed very well in countries. Same thing. Okay, I just I'll go to them. Okay, the same thing comes. You are able to see a Excel chart, spread chart over here.
You are able to see only your files, sir. You are not able to see the picture, sir.
Oh, 1 minute. I'll just go back. Now,
some Excel sheet has come.
Very good. So this is the small program what we have written. When you have a water sample, whether what is that being done is correct or not. This is a small example what we have. Instead of expressing it in milligram per liter, we make it as milli equivalent per liter for each of the compound. For example, if I change the value of this to 100, what happened to the bar chart? You see that. Okay, so it becomes. So the anion level and the cation level, if it matches, here we have got error as 0.25. For example, if I make it as 290, then the error diminishes. This is one way, instead of expressing everything in milligram per liter, making it to milli equivalent per liter, and we can satisfy that the sum total of anion in water and sum total of cation in water are more or less equal, then we say that the analysis is being carried out in a proper way rather. Because each of the parameters are discrete and are independent. They don't depend on that. And each of the cation and anion, for example, the sulfate may exist as magnesium sulfate, calcium sulfate, sodium sulfate dissolve in water. But when you find out only sulfate concentration, when you leave out the cationic this thing, when you plan it in a larger way, this is the better way of finding out whether this. So this is the one which I just wanted to exhibit, because yesterday only we have drawn this. For example, I will alter this value. You see that the change in the bar chart rather. So almost these should mash together. That is the one which I just wanted to impress upon. So major threat to groundwater, you are able to see the screen, sir?
No, not yet come. Only folder screen is there.
No?
No, not yet.
What is being visible to you?
Only files are there, sir. Only files are there. Folder files are there.
Now, sir?
Now it has come, sir. Now it has come. Groundwater making the invisible visible has come.
All right. So Major contaminants in groundwater in India is the salinity, which has been measured in micromole, fluoride, but the excess of fluoride in water, it causes what is called fluorosis. Deficiency causes what is called the dental caries, cavitation in teeth of infant. Nitrate, which is the causative for what is called the blue baby disease. And wherever you go, and Assam and other areas, the slow poison, arsenic, iron, and the lead, cadmium, chromium are what is called a neurotoxin. So this is the major threat to groundwater is unsewered domestic sanitation, disposal of liquid urban and industrial waste. Industrial waste, we don't have a ethic actually. Some of the industry are okay, but there are industries which pollute rather. For example, the tanning industry, because the major cause of pollution, both at the groundwater level as well as surface water. Polar water going a waste is because of that. Domestic and industrial waste is being let into it, accident and leak, acid, cultivation, agrochemical, that also because that has gone a long way and that has gone to a level called what is called the biomagnification. The LD50 value, we have crossed it actually. Some of the material which are carcinogenic and teratogenic, we are consuming. Salinity, of course, over withdrawal, urban wastewater, mining activities, and poor groundwater management rather. So changes with the depth in the earth crust, porosity is a major thing. Groundwater become more saline. So groundwater is being addressed in terms of climate change, economic, sanitation, health pollution, natural disaster, conflict, and human rights, because each of these activities are linked with the groundwater. So, yes, sir? You are able to see this?
Sir.
Groundwater, climate change has caused havoc at least. We say that globe is getting warmer. Same way we have got another concept also called global cooling also. And aquifer at that time when you are using it, it has got a buffering capacity and they are naturally more resistant to external impact than surface water. So, but if changes happen, it becomes an irreversible change. So natural disaster, conflict and human rights, aquifer can substitute after affected drinking water supply in time of catastrophic events like tsunamis rather. So groundwater is the only source. Even in Tanjavur Delta, most of the places in and around Kumbhakonam and Tanjavur, groundwater is a major source actually. So governance of water law and transboundary water. We have got a boundary between the country, but aquifer doesn't have a boundary rather. Because the problem is to address globally, like what you call the acid rain and air pollution problem. So various kind of ecosystem depends upon groundwater, aquatic wetlands, rivers, lakes receiving groundwater. All these things, the interdependency of the groundwater on the environment. Groundwater in settlement, of course, when you go to I don't know which part of the Chennai city, we have got a very good groundwater resources. And we can't expect it because the urbanization has spoiled the groundwater resources like and also pumping rate, the high rate with which we are pumping it, the confined aquifer also going as a disease. Water related disease, one of the major health concerns in the world. Groundwater can be polluted from because agriculture, what is that a chemical, what we are using, improper disposal of the sanitation and industrial waste, landfill, because the leachate is a big problem wherever you go for a solid waste dump. Okay, so 2/3 of the abstracted groundwater is used for agriculture. Of course, when groundwater is getting affected, it will have an impact on the agriculture also. Economy, everything depends upon the economy, right? Apply precautionary principle, and we have to understand that what is going on. Precautionary principle is a must. If you are not changing our this thing, the way after 2030, it is a great havoc, the scarcity, because the rising population, we are not be in a position to supply water to everybody. So groundwater is a vital source that provides almost half of all drinking water worldwide. Groundwater is an important part of climate change adaptation process and is a solution for personal access for safe water. World Water Day, let us think of it, let us not celebrate it, we observe it and take a call that it is our prime duty to sustain the water resources in India as well worldwide. When there is absolute scarcity, nobody can do a miracle. What is needed is not a miracle. We need a long-term sustainable solution to revitalize our rivers and groundwater. Thank you. Thank you. Thank you, sir. Sir, I am done with that.
Yes, sir, yes, sir. Thank you, sir. Thank you, sir. You unshare the screen, sir. Please unshare the screen.
Mr. Shelvaraj,
Yes, sir. Yes, sir. Yes, sir. Mahadevan, sir. Good evening, sir. Please, sir.
Can I ask a question?
Yeah. Please ask, sir. Please ask Dr. GS.
Yeah.
You can ask, throw your questions, sir. Yeah.
Good evening, Dr. Swaminathan. See,
good evening, sir.
Yeah. My question is this. Actually, around 2004, 2005, I was working with one Dr. Varadarajan. I mean, who firmly believed that taking anything from underground is always detrimental to human race. I mean, that seems very reasonable in the context of COP26 and net zero and carbon and all that, because the fossils being dug out of the earth, both coal and petroleum, seems to be the sole culprit of all this, global warming problem. That apart, you see, of course, we were working on solar pumping at that time, only on open wells and all that. But, I also wanted to add that in 2000, the earlier government under Vajpayee cleared one, this water scheme, that is National Waterways, which was designed by one Kamaraj, which doesn't talk about underground water, which talks about creating waterways, utilizing only the surplus water from all the rivers in the country and all that. It was really not about linking of water, linking of rivers. It was about taking the surplus water from various rivers. But somehow, unfortunately, I think that didn't get processed further because that Vajpayee government went, and now the present government is talking about the Godavari, Kaveri links and all that. But the water day today, the whole thing is focused to underground water, utilizing underground water, which sounds a little paradoxical. Anyway, I would like your comment on this.
Yeah, water resources, one thing is there, sir. How to tap the water. Water is available at a greater depth. Bringing the water to the surface also, the cost effectiveness is one criteria. Second criteria is over exploiting of the thing. For every action, there is a reaction rather. But something is underground, sometimes water is good, because in my own experience, in and around my home, we didn't get a good water. But when I went for a bore, I was able to have a very good yield, and the quality of water was very good actually. But later on, over a period of time, when you are drawing the water for more number of days and the year passed by, now that water has also become a saline water. But something, what is underground, the surface, we have to have a technology of finding out that is unexplored part of it. Today it happened to be good, actually we are exploiting that. One more thing is there, because for a time constraint, left it out. The treatment part of it, we have gone for what is called the RO process rather. RO process is supposed to take a water from the ocean, treat the water, but later on that is not also environmental friendly rather, because over a period of time only we learn from our mistakes. Probably this may be a good option, or tomorrow what we do may turn topsy-turvy also. I don't know whether what a way we have to answer the question.
Thank you, sir. Thank you.
Sir, Dr. G, sir, I have a query, sir. That is rainwater harvesting. How far it helps to recharge the groundwater levels?
Definitely, sir. Definitely. What is that? Your rainwater has helped us in getting a good yield in NIT Trichy.
So we are getting rain, you are enjoying.
I just want to add, whatever rain harvesting BHL has done, the beneficiary has been NIT. The same is the case with IIT Madras. Whatever they have done, the Belacheri was a beneficiary. See, whatever you say, the land under the ground, there is no boundary. When you recharge the water, it goes to every place. So you should not be selfish. You recharge, somebody else is going to be benefited to that extent. You just cannot.
So we have to get royalty from NIT.
It's not possible because it's all.
It's a wonderful talk, sir. I really enjoyed, sir.
Swaminathan, I must really thank Institution of Engineers for having selected our good friend, Dr. GS, for delivering this lecture. I still vividly remember when Dr. Panichami had brought him to Institution of Engineers, his very first lecture, I think it was on his thesis at IIT Madras. He shared with us at Institution of Engineers, and I had the fortune of attending to that meeting. And Dr. GS has been a very silent worker. He has helped me when I was in BHEL and also in my consultancy work. Especially he referred to about the phenolic waste and all. He has done a lot of work on those things. And one particular thing what he has told is very this thing regarding new water of Singapore. See, we have to follow such this thing. Only artificial recharge is going to help in improving the groundwater situation, and that has been demonstrated not only in Singapore but also in Orange County of California. Also, they have done it. They have been able to recharge the aquifers with artificial recharge, and I hope with the interconnection of rivers, automatically the Kaveri is going to be connected to Godavari. With this, I hope the en route, the entire place will be recharged and we will have copious water. Thank you.
Even in Panjati in Madras, they feel that they are over extraction of water, and then the treated sewage was pumped again into the ground, because the water board has advocated from 20 years back.
See, the treated sewage water pumping back into the ground is the best this thing. Only, as you have said in your lecture itself, the industrial water only is the culprit. The sewage water is as good as a good water. There is absolutely no problem. With the proper treatment of sewage water, we can recharge into the ground, and earth as a filter, it will filter the other this thing, and we can very easily use it That is exactly they have followed in New Water at Singapore.
Participants, if you have any query, you can ask, otherwise we can proceed to the next agenda. Thank you, sir. Swaminathan, sir, it was an excellent talk by you. We learned a lot from you about groundwater, what is the source, what is how to save for future. Really, it was a wonderful talk by you. Thank you so much. We enjoyed your talk. Thank you, Harsha, sir, for motivating us, inspiring us in all these areas. Thank you so much. I will move on to the next agenda. I'll call upon our secretary, Dr. Kevin R. Kumar, to announce the next week's program and propose vote of thanks. Over to Dr. Kevin R. Kumar.
Good evening, sir. Thank you. Thank you very much. Next week lecture program, that is on 29th March. The topic is oxytic metamaterials. The speaker is from University of Coimbra, Portugal. The speaker is Dr. Sri Sabari Shanmugam. He is a postdoctoral researcher at that university. So I invite you all for this lecture program. You can invite your friends and other colleagues. This program is totally free, and we will share the Zoom link for this one. You can invite all your friends and colleagues. Thank you. And I would like to thank the opportunity given to me to propose vote of thanks for this World Water Day lecture program. First of all, I would like to thank our past chairman and our former executive director of BHEL, Engineer G Swaminathan sir, for presiding over this function and for welcoming the gathering. I also thank our past chairman, Engineer Harsha sir, and our Selvaraj sir, for joining this program and gracing this occasion. I would like to thank our speaker, Professor Dr. Swaminathan sir, for giving a thorough insight into the program and pointing out that we need not celebrate, but we have to observe this day, and it's the right time for sustainability and to conserve to preserve the water and other things. I thank you for this wonderful insight into this World Water Day celebration, sir. Thank you very much. I would like to thank Dr. Titus for introducing the speaker of today. And I would like to thank Engineer Selvaraj sir for organizing this wonderful lecture program. I thank each and everyone for joining this program and gracing this occasion and making this World Water Day celebration a successful one. Thank you, one and all.
Thank you, Dr. Kevin. Thank you, GS sir. Good night, sir. Good night. Thank you for spending your valuable time with us, sharing your experience with us. Thank you. It was a wonderful talk. We enjoyed it so much. Thank you. Thank you. Thank you. Thank you. Thank you, everyone, participants. Thank you. Good night, everyone. Good night.
Thank you, sir. Thank you. Thank
Yes,
you.
sir. With the permission, I'll close the program. Thank you. Thank you.
Thank you, sir.
Good night.
Yes.